Good afternoon. I'm Angela Schroeter. I'm a senior engineering geologist at the Central Coast Regional Water Quality Control Board. And today I'm going to give to you a talk about the groundwater monitoring and drinking water protection activities in the Central Coast region. I had intended on being here today with one of our district engineers, Jan Swigert, from the Division of Drinking Water, but she was unable to be here, so I'll be giving a few of her slides. So as this is an overview, I'll give you a background on the agricultural order, an overview of the groundwater monitoring and reporting requirements, a summary of our grower compliance and implementation, as well as a summary of the groundwater results. I'm also going to describe to you how the Water Board is using this data and then present to you a couple of drinking water case studies if I have time. So just for context, this here on the left is a map of California. This is the Central Coast region. We're Region 3, one of 9 regional board offices. Different from the Central Valley, the Central Coast region has 435,000 acres of irrigated land. Because of our climate, we have high-value crops, specialty crops such as lettuce, broccoli, and strawberries, and some other commodities. And these are under intense crop production because of our climate, so we have multiple rotations in these areas. Also different from the Central Valley, we have approximately 4,000 farms enrolled in our irrigated lands regulatory program. So our Central Coast Water Board is very committed to working with the ag community as well as with the environmental justice community and the communities reliant on groundwater for drinking water. But our role is to regulate the discharge from irrigated agriculture and to protect water quality, especially drinking water resources. So just a little bit of background on the agricultural order. Our order was developed in March of 2012. It was actually an update. Our first order was in 2004. This order includes groundwater monitoring and reporting requirements for irrigated agriculture in California for the first time. So really, this data should be viewed as a starting point. It definitely is just initial groundwater monitoring, and so we'll be working on improving these requirements in the future. The order does prioritize drinking water and nitrate in groundwater. So the purpose of the groundwater monitoring and reporting was to provide an initial characterization of groundwater quality in our agricultural areas, to identify and prioritize the farms and areas that are at increased risk for pollutant loading and drinking water pollution, as well as to identify areas where we need to improve our nutrient management. Finally, we also wanted to assess impacts to beneficial uses, especially those domestic wells in our rural areas that are not regulated by our Division of Drinking Water. We wanted to make sure that those users were well informed about the safety of their drinking water. So just a summary of the requirements here. So in the Central Coast region, growers have the opportunity to comply as individual growers or as part of a cooperative. So we have the fortunate ability to work with 2 cooperatives. The first is the Central Coast Groundwater Coalition. That coalition is region-wide. It's led by Perry Clausen, who also leads the Eastern San Joaquin Valley Coalition. We also have the Santa Rosa Creek Cooperative. They're a very small cooperative in northern San Luis Obispo County. In terms of parameters, both growers who comply with the individual requirements as well as the cooperative requirements, they oops, sorry. They have to sample for nitrate, major ions, TDS, pH, and alkalinity. They also report well location. So we have the latitude and longitude for each of the wells that are sampled, as well as well construction information if it's available. Although I should mention, as you all are aware in California, well logs are oftentimes difficult to review, and so our information about depth and screened intervals is very limited. One of the aspects of our groundwater monitoring requirements is that it's only for existing wells. So our Central Coast Water Board was very deliberate about not adding additional costs to growers to install new wells or to drill monitoring wells. So the data you'll see today is for existing wells only. In terms of what types of wells are sampled, for individual wells or individual growers, the requirements require growers to sample all drinking water wells on their enrolled properties, as well as the primary irrigation well. And frequency that's required is 2 samples in the first year, a fall and a spring sample. So that our agricultural order is a 5-year permit, and so growers are required to sample those wells twice in the first year. In terms of the cooperatives, there's much more flexibility in the requirements. So cooperatives basically develop a work plan, and then that work plan is submitted to our office for approval. But at a minimum, cooperatives must sample all drinking water wells. So in terms of statistics, just a reminder that our order was adopted in March of 2012. So at that time, we had no groundwater data for the Central Coast region. Now, fast forward to 2016. In March of 2016, we had sampled and received data for almost 4,000 groundwater wells. In terms of well type, we have 1,733 drinking water wells. Those are on-farm domestic drinking water wells, and 2,300 approximately irrigation wells. So, summary of compliance. We are very fortunate on the Central Coast. Our growers are very proactive in achieving compliance, and we have a high level of compliance actually for many elements of our agricultural order. I'm just presenting to you here today groundwater monitoring. So in 2014, we did our first initial review of compliance and found that 74% of the domestic drinking water wells on farm had been sampled. It's a very high level of compliance, especially considering it's the first time requirement for the Central Coast region. 75% of the irrigation wells have been sampled, and we had issued about 380 notices of violation to get those growers who had not yet complied sampling their wells. In 2015, we did another compliance evaluation, had a significant increase in compliance, so 91% of the drinking water wells have been sampled, 76% of the irrigation wells have been sampled, and again, we did issue a few notices of violation to some individual growers. In 2016, we also received the required deliverables from the Central Coast Groundwater Coalition. So the Central Coast Groundwater Coalition is required to also produce groundwater characterization reports, and it's basically an interpretation of the data. So we did approve characterization reports for the northern and southern parts of our region. So this is a map here of our region, Monterey Bay, Salinas Valley, Santa Maria Valley, then the south coast here, Santa Barbara. So each of these dots here on this map represents a well that's been sampled in compliance with the order. The orange and dark red well or circles here are groundwater wells that exceed our drinking water standard. So in all of these areas, groundwater is designated as drinking water beneficial uses, and the drinking water standard is, as you know, 10 milligrams per liter nitrate as nitrogen. So in summary, in terms of statistics and percent exceedances, you'll see that 26% of our wells overall in the Central Coast region exceed the drinking water standard. So we do have a very significant nitrate impact to groundwater. 10% of our wells, shaded there on the pie chart in dark red, exceed the drinking water standard by more than 3 times. If we just look at drinking water wells alone, 25% of the groundwater wells that serve drinking water, and these are domestic drinking water wells on farm, exceed the drinking water standard, with some as high as 188 milligrams per liter nitrate as nitrogen. So that's 18 times the drinking water standard. Irrigation wells, of course, folks aren't drinking from irrigation wells, but still we have fairly high levels of nitrate and also 26% exceeding the drinking water standard. So in terms of how this plays out by county, these here are the counties in our region, and I've broken it up by domestic drinking water wells and irrigation wells. You'll see that there is a range of the percent exceedances of our results, but we do have an issue in all parts of our region, and we can focus a lot of attention here on Monterey County, especially the Salinas Valley, where we have 40% of our domestic drinking water wells on farm exceeding the drinking water standard. And an important thing to remember about this data is that it represents the on-farm domestic drinking water wells. There are many rural households that are not enrolled in the agricultural order, neighbors of farms, or just nearby farm communities. So these are drinking water wells that are not included in this data set, but may be at risk. So in terms of groundwater data management, one of the things that the UC Davis Nitrate report specified was this real great need to integrate data and to make it very accessible. So part of our agricultural order is to require that this groundwater monitoring data be submitted to the Water Board electronically and directly from certified labs. So we have EPA certified labs analyzing that data. The data goes directly to us online and is available in this our data management system called GeoTracker. So this is a screenshot here of GeoTracker, and what it does is it makes it publicly available online for display, analysis, and download using this online tool. So anyone can go online and download all data for these 3,000 wells, nitrate, as well as all the other parameters. The Central Coast Groundwater Coalition characterization report is also available online, and it includes some interpretation. Here's an example of a nitrate concentration contour map that was produced by Ludwig Scalmanini for the Central Coast Groundwater Coalition. So how do we use the data? Well, the first thing we do is, of course, is to sort of field verify our conceptual models and conducting this initial characterization of groundwater quality. Again, it's limited because you don't have information on depth and screen intervals. This is just shallow domestic wells and irrigation wells. We prioritize areas for follow-up and to evaluate and minimize nitrate loading. We also require drinking water notification letters. So I mentioned that domestic wells in California are not regulated. They're not monitored, and oftentimes folks don't know the quality of their drinking water. So we do require landowners and operators to notify the well users of their water quality. We also work with the Community Division of Drinking Water, county environmental health offices to make sure we can try to obtain safe drinking water where it's needed. So, for example, these pictures here are pictures of the San Lucas community. This is the elementary school. They're well exceeded the drinking water standard, and they were funding bottled water on their own. We worked with the growers to obtain replacement water both through interim bottled water as well as a new well. That arrangement was documented in a cleanup and abatement order, but I do want to say that those growers and landowners were very proactive in helping the community get that clean drinking water. We also support projects that test innovative treatment, both for drinking water as well as for discharge from farms. So now I want to present to you a couple of case studies where nitrate is real in terms of impact to drinking water systems, and it's having a significant cost to the communities. So Iris and Jack's Apartments, they're a community in Monterey County. They are a very small community, serves 150 people, severely disadvantaged low-income community. Their drinking water well became contaminated up to 2 times drinking water standard. They did apply for state funding and received it for bottled water at a cost of $17,000 for 2 years. We are also able to get them a new nearly 1,000-foot well plus storage at a cost of $355,000. The community has safe drinking water now, so that's a success story. Apple Avenue is another system in Monterey County, which is not quite as successful. It's another small community west of Greenfield, serves 60 people. It's also in agricultural areas, severely disadvantaged low-income community. Their drinking well is up to 4 times the drinking water standard. State funding provided an alternatives analysis to identify a solution to the drinking water problem. That cost $48,000, funded by grants. It did identify that hookup to the city of Greenfield was the best solution. The community has applied for funds to connect. However, those funds have not been obtained, so the community still does not have safe drinking water. The County of Monterey has placed them on a do not drink order, and so residents of that low-income residential community are on their own for providing safe drinking water. So just some take-home messages. We are successfully implementing the groundwater monitoring and reporting for irrigated agriculture. There's a very high level of compliance among growers. Data is very important to inform well users as well as growers. We have many, many reports of well users and growers sort of learning this information for the first time when they sample their own well. The results do continue to show severe nitrate impacts to groundwater, especially in the areas of Salinas Valley and the Santa Maria Valley. So it's critical to reduce nitrate loading now. But we know that improvements to groundwater will take time. The challenge is how do we secure safe drinking water while we wait for the groundwater improvements to happen. And so consistent with the human right to water law in California, this is a very high priority for our board in terms of both reducing the nitrate loading and finding solutions to the drinking water problem. So with that, I'll just acknowledge our partners, growers and landowners, County Environmental Health, the Central Coast Groundwater Coalition, as well as the Environmental Justice Coalition for Water. And then this is our contact information on our website if you have any other questions or details. Thank you.
Thank you, Angela. And we have time for questions.
Thanks for your presentation. Just a quick question. What's your perception on who benefits from and who uses primarily the data that's input on GeoTracker about well exceedances?
Well, so what's in GeoTracker is all the data, right? It's the location information, it's all the parameters, the major anions and cations, as well as the nitrate. Prior to GeoTracker, we were getting, I would say, tens of public requests for information. So one thing about GeoTracker just allows the public to go directly to the website. We've gotten lots of requests actually from the agricultural community for the data, lots of requests from researchers like at UC Davis, lots of requests from consultants and others who are looking at areas to test innovative nitrate treatment. UCLA is an example of one.
So just wondering, the community that got the nearly 1,000-foot well, what are their monthly water bills?
That was Jam's part of the presentation, so I don't have the exact number of the monthly water bills. I do know that there is a significant affordability issue, so that community's water rates have gone up, which is not uncommon.
Other questions?
Yeah, thank you for your presentation. I wondered, does the Water Board has the ability to force farmers to change their farm practices? And if so, are you planning to have a plan to change their practices so the water quality will be good in the future?
So that's a great question. And there's significant debate about how we go about doing that. I would say that the Water Board, per the California Water Code, absolutely has the authority to make requirements that growers don't pollute the groundwater. The key thing about that is we don't have requirements that prescribe how a grower can do that. So it's really up to the growers, the industry, as well as the technical assistance providers to determine the best way of doing that, which is great because it can be site-specific and allow flexibility. We are struggling with the fact of what are the metrics, right? How do you measure loading and how do you measure whether or not sufficient improvement has been made?